Hi, Les West here. In this video I want to explain what we mean by scientific notation, how to write it, how it may be used in real life, how to perform calculations in it, and a couple of tricks to make it easier. Before we start, you will need to understand the basic laws of indices. If you've seen my YouTube video on this, you'll be well prepared. But if not, you should ensure that at least you understand how to multiply and divide expressions where the base is raised to a power. Scientific notation is a way that mathematicians, engineers and scientists, among others, are able to express very large or very small numbers in a sort of shorthand. Here's an example of scientific notation. We are expressing the number 4,130,000 as 4.13 times 10 to the power of 6. 10 to the power of 6 equals 1 million. So 4.13 times 1 million is equal to the number we want to express. Now, for the expression to be called scientific notation, the base number, 4.13, must be more than 1 and less than 10. So we don't write 41.3 or 413, but 4.13. The power to which we raise 10 is called the exponent. That was an example of using scientific notation to express a large number. If we have a very small number, we express the exponent as a negative. So in this example, where we have 0.50413, we can express it as 4.13 times 10 to negative 6. And by the way, you may sometimes see scientific notation referred to as standard form, but this is mainly in British textbooks. Before we get down to working with scientific notation, let's look at a few examples of its use. The world's tallest building now in 2021 is the Burj Khalifa in Dubai. I have seen its height written as 8.28 by 10 squared meters, which is 828 meters. Our planet Earth is a tiny dot in a vast galaxy called the Milky Way, whose diameter is 9.5 times 10 to the power of 17 kilometers. At the equator, the circumference of the Earth is 4 times 10 to the power of 5 kilometers. If you've ever been stung by a mosquito, you might be interested to know that the bit that it's using to sting you, which is called its proboscis, is about 4 times 10 to negative 2 millimeters thick. And that coronavirus we're all worried about is about 8 times 10 to negative 5 millimeters long. So it's easy to see that most of these dimensions are far more easily expressed in scientific notation than in ordinary numbers. Okay, let's look at the first of our little tricks in writing numbers in scientific notation. First of all, let's be clear that if you see a number such as this, 41.3 times 10 to the power of 6, this is not in scientific notation, because the base, 41.3, is not between 1 and 10. So the first trick to learn is, if you have a positive exponent in a scientific notation, then to write it as an ordinary number, you simply move the decimal point to the right by the number of places indicated by the exponent. So in this example, we've moved the decimal point from immediately after the 8, 7 places to the right. And if we have a negative exponent, we move the decimal point to the left by the number of places indicated by the exponent. So that should make it simple for you to understand how to convert a scientific notation to an ordinary number. But what if you were being asked to convert an ordinary number to scientific notation? Well, if the number is very large, as in this example, 432 million, then you move the decimal point to the left until the base is between 1 and 10, 4.32 in this case, and count the number of times it has moved to give you the positive exponent, in this case 8. So the answer is 4.32 times 10 to the power of 8. And if the number is very small, then move the decimal point to the right and count how many times it moves to give you the negative exponent. As in this case, the decimal point has moved past 10 zeros and past the 8 to give us the answer 8.12 times 10 to the power of negative 11. Now for some problems you may get in your mathematics studies. First of all, you may be asked to put scientific notations in order, as in this question, where we have to put 6 numbers in order from the smallest to the biggest. The first thing you have to do is look to see if any of the 6 numbers have the same exponent. In this case, we have 2 examples, 7 and 6.14. Both are times 10 to the power of 5. So we put those two in the order of the base numbers. 6.14 is lower than 7, so it will go before it. For the rest, it doesn't matter what the base number is, because their order will be the order of the exponents, from the smallest, which is negative 6, to the biggest, which is positive 5. So the order is as shown. Now let's look at what you do if you're asked to add 2 numbers in scientific notation. Well, first of all, you convert the scientific notations to ordinary numbers, as I showed you before. So 6.12 times 10 to the power of 4 is 61,200, and 3.8 times 10 to the power of 5 is 380,000. And if you then add those ordinary numbers, you get 441,200. And if you move the decimal point to the left, as we saw before, we get the answer 4.412 times 10 to the power of 5. And subtraction is a similar process. Convert the scientific notations to ordinary numbers, subtract them, and then convert the answer back to scientific notation as shown before. So here's our question, 3.4 times 10 to the power of 6 minus 2.81 times 10 cubed. 3.4 times 10 to the power of 6 is 3,400,000. 2.81 times 10 cubed is 2,810. Subtract 2,810 from 3,400,000 and we get 3,397,190. And if you move the decimal point to the left, as we saw before, you will get the answer in scientific notation, 3.39719 times 10 to the power of 6. The process we use when we're asked to multiply 2 numbers in scientific notation is a little different. First of all, we take the base numbers, and in this example the base numbers are 3 and 2, and first of all we multiply those to give us our new base 6. Then we take the exponents, 10 to the power of 4 times 10 to the power of 8. Now, if you remember the laws of indices, you will know that we have to add the exponents. So 10 to the power of 4 times 10 to the power of 8 equals 10 to the power of 4 plus 8, 10 to the power of 12. So the answer to our question is 6 times 10 to the power of 12. But if you're doing multiplication questions, here's a little trap to beware of. In this example, we're being asked to multiply 6 times 10 to the power of 8 by 7 times 10 to the power of negative 2. Well, 6 times 7 is 42, and 10 to the power of 8 times 10 to the power of negative 2 is 10 to the power of 6. But this answer is not in scientific notation because 42 is not between 1 and 10. So we have to convert 42 by dividing it by 10, giving us 4.2, and we have to multiply our exponent by 10, giving us 10 to the power of 7. So the correct answer to this question is 4.2 times 10 to the power of 7. Division is a similar process. Here we have an example: 12 times 10 to the power of 7 divided by 3 times 10 to the power of 4. We divide the base numbers. 12 divided by 3 gives us 4, and we divide the exponents. 10 to the power of 7 divided by 10 to the power of 4. Under the laws of indices, when we divide exponents, we subtract the indices. So 10 to the power of 7 divided by 10 to the power of 4 is 10 to the power of 7 minus 4, which is 10 cubed. So the answer is 4 times 10 cubed. And a second example: 9 times 10 to the power of 8 divided by 12 times 10 to the power of 14. Now 9 divided by 12 is going to give us 0.75, and 10 to the power of 8 divided by 10 to the power of 14 is going to give us 10 to the power of negative 6. But again, this is not scientific notation because 0.75 is not between 1 and 10. So we multiply the left-hand side by 10, giving us 7.5, and that means we need to divide the exponent by 10, giving us 10 to the power of minus 5. So our answer is 7.5 times 10 to negative 5. So we've added, we've subtracted, we've multiplied, and we've divided scientific notation numbers. Now for the second little trick, and this is one I'm sure you'll like, because no one in real life ever does these calculations manually. You use your calculator. A scientific calculator has a button called the exponent button, and this button is normally labelled EE for exponent. If you have an iPhone and you open the calculator app on your iPhone and you turn the phone sideways to display the format as landscape, the calculator becomes a scientific calculator, and you will see this button. There it is, EE, meaning exponent. So let's see how we use the exponent button. Well, suppose we had the expression 1.45 times 10 to the power of 6, and we wanted to show that as a normal number. On the calculator, enter 1.45, then your exponent button, EE, then enter 6 so that you've got the exponent to the power of 6, and then hit the equals button. And the calculator will show you that 1.45 times 10 to the power of 6 equals 1,450,000. But if you have an expression, a scientific notation expression with a negative exponent, as here 1.45 times 10 to negative 6, then you enter your 1.45, your EE exponent button and your 6, and then you hit the plus and minus button to make the 6 equal negative 6. Then hit your equals button and the calculator will give you the answer 0.000000145. Now suppose we had entered 23.8 times 10 to negative 34. So we enter 23.8, exponent button, 34 plus or minus equals, and the calculator tells us this is 2.38e to negative 33. Now it's done two things here. First of all, it said this is not in scientific notation, so I've got to move the decimal point to the left to make it 2.38. Then I've got to multiply my exponent by 10 to give me 10 to the power of minus 33, and it shows that exponent as e minus 33. So you can see how the calculator shows you a number in scientific notation using e as the exponent, but why didn't it give us the answer as a normal number? Well, simply because your calculator is not big enough to put all those zeros in and 238, which would be the answer as a normal number. Now let's look at a couple of questions which might occur in real life. Let's say a scientist is trying to find the frequency of light which has a specific wavelength, and his calculation might look like this: 3 times 10 to the power of 8 divided by 6 times 10 to the power of negative 7, and the units are hertz, which is equivalent to cycles per second, which is the way frequency is expressed scientifically. So he would enter the following sequence into his calculator: 3 exponent 8 divided by 6 exponent 7 plus or minus equals, and he would get the answer 500 million, which we know, because we've counted the zeros, equals 5 times 10 to the power of 14 in hertz. But suppose you'd wanted your calculator to show you the answer not as a big number, 500 million, but as a scientific notation. Well, here's another little trick. When you entered the numbers and got the answer as 500 million, simply turn your calculator sideways again. So instead of landscape, it's in portrait mode, and you'll see the answer is now in scientific notation as 5e14, meaning 5 times 10 to the power of 14. And here's another little real-life problem in which the calculator will give us the answer as scientific notation. In this case, the scientist is trying to calculate the energy of light which has a given frequency, and the answer will be in units called joules, which are units of energy. So the equation is 2.5 times 10 to the power of 12 multiplied by 6.626 times 10 to the power of negative 34. So we will enter 2.5 exponent 12 times 6.626 exponent 34 plus or minus equals, and the calculator will give us the answer in scientific format: 1.6565 e to negative 21, which we can write as 1.6565 times 10 to negative 21 joules. Well, I'm sure you'll find using your calculator much easier than doing these calculations by hand. Let's just recap on what we've learned today. Scientific notation, which I've abbreviated to SN. We've learned how to convert from SN to normal numbers. We've learned how to convert from normal numbers to SN. We've learned how to order numbers in SN, to add and subtract numbers in SN, to multiply and divide numbers in SN, and possibly most important of all, we've learned to use a scientific calculator with SN. So hopefully now you know a little more about scientific notation, how and when to use it. I hope you'll join me for another video soon. So goodbye for now.